Okay, so I've made this presentation to help you with question 2 of the LV02.2k written assessment. Question 2 is, as you can see, relates to light vehicle fuel systems and emissions, and part A of question 2 is state the 4 main gas pollutants generated by a spark ignition petrol engine. Okay, so last week I told you a bit about the combustion process. This was when I was telling you a bit about EGR valves, or exhaust gas recirculation. But hopefully you can remember that all fossil fuels are a form of hydrocarbon, so petrol, diesel, coal, etc. They're all various forms of hydrocarbon, and to make them burn we need to mix them with air, which is a mixture of oxygen and nitrogen and a few other bits and pieces, but these are the main constituent parts. Okay, and if you remember from last week, I was saying that basically what we do is we take the hydrogen from the hydrocarbon and oxidize it, and that forms H2O, which we know as water. So it comes out of the exhaust pipe as superheated steam. So you can't necessarily see it, but it's there. And we take the carbon from the hydrocarbon and we oxidize that as well, and we produce carbon dioxide, CO2. Now the nitrogen will, let me just move the slide on. If we have an air fuel ratio of 14.7 to 1, so 14.7 grams of air for every 1 gram of fuel. This is the ideal air fuel ratio. It's called stoichiometric, and if we have those conditions, then the nitrogen will remain inert and just goes through the engine and through the exhaust pipe and comes straight out the other end and doesn't react. Okay, so if we change the fuel mixture, if we deviate from the 14.7 to 1, and in the example I gave you last week, I suggested we could go with a weaker mixture. So that's more air, 16 grams of air, less fuel, so the same amount of fuel, 1 gram. If we run on this weaker mixture, we will produce more heat. It's actually much more efficient in terms of producing heat. But the problem is that now the nitrogen oxidizes and we produce oxides of nitrogen. So that's a bad thing, alright, that's a dangerous gas. Okay, we could also deviate the other way with our fuel mixture. So instead of running on a weaker mixture, we could run on a richer mixture, so that's less air to the same amount of fuel. And in either of these cases, if we deviate away from the ideal air fuel ratio, we are going to have problems with combustion. We're going to have incomplete combustion. And so what that means is, in the case of our carbon, if it's not fully combusted, if there's incomplete combustion, we will produce, instead of carbon dioxide, which is 1 atom of carbon and 2 atoms of oxygen, we will produce carbon monoxide, which is 1 atom of carbon with 1 atom of oxygen. That's because there's less air, so therefore there's going to be less oxygen. So we start to produce carbon monoxide instead of carbon dioxide. And also, either way, if we deviate away from that ideal air fuel ratio, there is the chance that some of our fuel won't ignite at all. I'll explain that in a little while in a bit more detail. But when that happens, some of the petrol goes through the combustion process and that comes out of the exhaust pipe as well. So these are our bad emissions, if you like. So hydrocarbon is not good because it affects global warming and climate change. It causes the greenhouse gas. It is considered a greenhouse gas. Carbon monoxide is dangerous to us as humans. If we, given the choice, our lungs will absorb carbon monoxide rather than oxygen. So if you know, hopefully you know that if you don't get enough oxygen, you're going to die. So if your lungs take this instead of oxygen, basically you die. Carbon dioxide, all right, although it's relatively harmless, it's what's used to make your drinks fizzy and things like that. The problem is, at the moment, we are producing way too much of it. There are too many cars on the road, and also on top of that, we are cutting down lots and lots of trees which would normally take the carbon dioxide, and they then break down the carbon dioxide. They turn the carbon into wood and plant materials, and they give off the oxygen which we breathe. So, as I say, carbon dioxide isn't really a dangerous gas, but the problem is we're producing way too much of it. So for this assessment, I'd like you to consider that as a pollutant as well. So unburnt fuel is hydrocarbon, carbon monoxide, carbon dioxide because we're producing too much of it, and the various oxides of nitrogen. Okay, so there they are. They're the harmful gases. There's the 4 of them. Now these are produced in a petrol engine. Let's just have a look at, I'm going to compare petrol and diesel engines here. So this is not a very clear diagram, but it's a diagram of a fuel injection system, which we will be learning about at some point. This is actually a fairly old-fashioned one. Anyway, now's not the time to talk about fuel injection systems in massive detail, but basically what this diagram shows us is that this is the piston moving up and down inside my engine, and this is the inlet manifold. So my air filter would be over here, and the air flows through the air filter and through the inlet manifold, and this component here is the fuel injector. So you can see in yellow that's meant to be the fuel being squirted into the flow of air as it goes into the engine. So what goes into this part of the engine, the combustion chamber, is air and fuel fully mixed. So we fill the whole chamber with fuel and air, all right? And then obviously it goes through the 4-stroke cycle. Let's bring up a diagram of the 4-stroke cycle, which we know. So we've got intake, compression, power and exhaust. And you know that there's a spark plug in a petrol engine. All right, that's one of the questions that will come up in a moment. Okay, so what I need you to appreciate at this stage is that in a petrol engine, air is drawn in through the inlet manifold and fuel is injected into that flow of air before, generally speaking, before it goes into the engine. So what goes into the combustion chamber and fills the combustion chamber is a fully mixed up mix of fuel and air, which is then ignited by the spark plug. Okay, let's compare that to a diesel engine. In a diesel engine, we don't have a spark plug, and I'm just going to run this video just to remind you. I know you've seen this anyway, but I'm just going to run it again. Sorry, I lost my cursor there.
We need a fuel, or something that burns easily. Place a small amount of cotton fiber at the bottom of the tube. Make sure that the cotton is clean and dry. Press down rapidly on the piston. The increase in pressure causes the air's temperature to go up so much that the cotton
catches fire. Sorry, I cut him off a bit short. So what that video is showing you is that in a diesel engine, if we have a high enough compression ratio on the compression stroke, so the piston comes up. Imagine there isn't a piston in, a spark plug in this one. The piston would come up. It compresses the air so much, as you saw in the video there, it gets hot enough to ignite the fuel. So in a diesel engine, here we've got a diagram. This is the piston running here, and you can see the injector. This is the injector, and the fuel squirts into the really hot air. So the point is that in a petrol engine, this whole chamber would be full of fuel and air mixed together, whereas in a diesel engine, all that comes in is fresh air, clean air. And so what's highlighted in yellow on this diagram is just air, and then we squirt the diesel into it. So the diesel is contained or suspended in the middle here, and the fuel, the diesel, doesn't actually get to touch the sides. Now that's important because basically what's going to happen, the air just comes in, as I said earlier, and because it doesn't, because the fuel is injected into it through my fuel injector, we keep the fuel in the middle, and it, as I say, it doesn't touch the sides, and so we don't get end gases. And I mentioned end gases in a previous video. I'm just going to run a snippet of that video. So
I've drawn a cross to represent the spark of a spark plug. Once the spark initiates combustion, the flames spread progressively downwards. However, the gases that are in contact with the cylinder wall will be much cooler because much of their heat will have been conducted into the metal of the cylinder wall. These gases are referred to as the end gases, and they are much more difficult to ignite, and sometimes they don't ignite.
Okay, so this was a petrol engine. I forgot to mention that, and my cross here represents a spark plug in a petrol engine. And because the whole chamber is full of a fuel-air mixture, those gases that are touching the cylinder wall here, or the edge of the combustion chamber, as I mentioned, are going to be much, much cooler. So there's a chance that they won't ignite. And that's the hydrocarbon. Remember, that's fuel. And we said some hydrocarbon can go in and not be burnt and then comes out of the exhaust pipe. So that's what that is. Those end gases form that hydrocarbon that comes straight out of the exhaust pipe. But in my diesel engine, sorry, let's just go back. In my diesel engine, because we're only drawing in fresh air, there are no end gases. We're injecting the fuel into the middle of it, and so there are no end gases as such. And so as a consequence, we don't have hydrocarbons, or not too many of them. So they're so few that we can virtually ignore them. So just to summarize here, the four main gases that come from a petrol engine, all right, pollutants that is, are
hydrocarbon, carbon monoxide, carbon dioxide, and oxides of nitrogen.